All right, so let's look at, and we will review limits and see how to evaluate them graphically and numerically. And this is all review. So let's see what we've seen before with limits. So when we look at this graph, there's a point is missing at 1, 2, and we should think about things like what's the closest point on the line to the missing point. So maybe someone would say if we had an x value of 1.1 and that y value, that point would be the closest point to 1, 2. But really there's no closest point, because if I say that 1.1 is the closest x value, then we could just go to 1.01 and keep getting closer and closer to 1, but never finding the closest point to the missing point. We can describe what's happening to f, what's happening to the graph as it gets close to that missing point, and that is what we're going to do with limits. So let's describe the behavior of f near x equals 1, and we can say so that describes what's happening on the graph. Another way to say that is so we'll be using this notation, and let's think about what this is saying. We're going to focus on identifying where on the x-axis we're going to look, and then follow what's happening to the y values. So what's happening, let's describe some of the points on this graph, or missing points. Describe the behavior of the graph, and we can say that the limit as x goes to 2 of f of x. So we find 2 on the x-axis and follow the graph. From the left, the graph, the y value is going towards 1, and from the right, the y value is going towards 1, so the limit is 1. And what's the y value approaching as x goes to 4? So we find 4. Let's follow the graph from the left, and the y values are approaching 3. From the right, the y values are also approaching 3, so the limit is 3, even though there's no point. The function is undefined at x equals 4. And we can say that as x goes to 0, what's the graph doing? As x approaches 0 from the right, y is going to infinity, and from the left, y is going to infinity. So we can say the limit is infinity. If it's doing, for all of these, the y values have to approach these values from both sides, from the left and the right. This should be an open circle. All right, so we have open circle here, here, and here. And let's find these limits. The limit as x goes to 0 Okay, pause the video and find these limits. As x goes to 0, here's 0 on the x-axis. What's happening to the graph from the left? It's going to infinity. From the right, it's going to negative infinity. So because the graph is going to in two different directions, we say that this does not exist. As x goes to 1, here's 1, and from the left, the graph is approaching 1. From the right, the graph is approaching 2. So that limit does not exist. And we'll go to 2. From 2, the graph is approaching 3. From the left, the graph is approaching 3. From the right, the graph is approaching 3. So we know the limit is 3. Even though the function has a value of 2, the limit has a value of 3, or the limit is 3. Okay, so if we find these limits graphically, we have an open circle around there, y-intercept of 1/2, vertical asymptote at -2. And we can look at the graph at x equals 2. We can estimate that looks like it's about 0.25. It turns out it is 0.25. And at 1, we can look at that value, and that looks like it's a little, maybe between 1/2 and 0.25, so 1/3. So we can estimate the values from the graph. let's look what's happening numerically. If we're finding the limit at 2, we need to choose x values that are close to 2 from the left and from the right, and then using a calculator with that function we get 0.256, 0.25, undefined, 0.249, 0.2439, and we look for what's happening with these numbers. They look like they're approaching 0.25. These numbers are approaching 0.25, so it looks like the limit is 0.25. And let's also look at it if we just substituted. That's 4 minus 4 is 0, 0 over 0. So we'll talk more about this later. That's called indeterminate. And if that occurs, we can always look at the limit numerically. And we know that from both sides, the y values are approaching 0.25, even though we have the value is undefined if we substitute. And this corresponds to that open circle. We can also evaluate this. Just with substitution, put a 1 there. We got 1 minus 2 over 1 minus 4. So that's 1/3. So let's just do this one graphically and numerically, and we'll just do this with substitution. So pause the video and try those. So just looking at this one, if we graphed it on the calculator, we have a point at somewhere around here, and -3, the value is -0.25. That's an open circle. So to evaluate the limit at -3, we look for the y value of that open circle. What's the graph approaching from both sides? And from the graph, using a calculator, we would see that it's approaching -0.25. But we can see that more clearly with a table. We have to get close to -3. If we substitute -3, it's undefined, 0 in the denominator and 0 in the numerator, so that's undefined. It's indeterminate. And using the calculator, we have these values. and we see that from the left and the right, y values are approaching negative 0.25. So we can say that the limit as x goes to negative 3 is negative 0.25. We can evaluate this with substitution, and we could also look at it numerically and graphically. When you put a negative 1 in there, 1 minus negative 1, negative 1 plus 3, so we have radical 2 minus 2. We evaluate all that, and we have approximately negative 0.2929. So we can evaluate a limit at any x value. We're not just going to evaluate limits. Well, usually the questions are asked about these unique points, but you can evaluate a limit anywhere, and that's why we looked at negative 1, because there's nothing special about it. We just find the y value, and that's the limit. If we evaluate this using substitution, we already have something that's undefined, so we have to look at it graphically. And using the calculator, we see this happening. And when we look at it numerically, we're trying to see what's happening at 0. Looking at the graph, well, that's a new looking graph. What's happening there? As x goes to 0, we're going to get really close to 0, and here we have negative 5.06, and over here at positive or negative 0.01, we're going to be at 0.506. So it doesn't look like it's going to the same place. It turns out this is called, the limit does not exist, and this is called oscillation. So the limit does not exist due to oscillation. All right, so try this with your calculator or Desmos. Evaluate this limit graphically and numerically. Pause the video. So we have we can see that from the left, the y values are approaching 1. From the right, the y values are approaching 1. At 0, the function is undefined. So we see that the limit is 1, the y value is 1, but the function is undefined, and the graph looks like that, and we can see the limit is 1 from the graph. All right, we also have to review piecewise functions. These are pretty common with limit questions. So let's look at the parabola to the left of 1, open circle, and we'll look at this line with a y-intercept of 1, and then up 2 over 1, up 2 over 1, closed circle. And now we can say, what's the limit of f as x goes to 1? From the graph, we can see that from the left, it's approaching 1. From the right, it's approaching 3. So the limit does not exist. And if we look at that numerically, we want to approach 1, get close to 1. Remember that to evaluate this, we're using 2x plus 1 for all of these, and we're using x squared for these. When you evaluate it at 1, we get 3, 3.02, 3.2. And this is approaching 3, and this is approaching 1. We see that the limit does not exist. Pause the video and try this one graphically and numerically. So to the left of 0, we have a y-intercept of 2, and we include the y value at 0, so that's a closed circle with a slope of 1. To the right of 0, we have a y-intercept of 2 and a slope of negative 1. And what's happening to the y value as x goes to 0? Follow the graph from the right. The y value is approaching 2. From the left, the y value is approaching 2. So the limit is 2. And we can also show it numerically. We need to get close to 0. And you can pick any numbers that are getting close to 0. If you wanted to go to 0.001, that's fine. So from the left, these numbers are approaching 2. These numbers are approaching 2. The value is 2, the value of the function. Remember that for these values, we are using negative x plus 2. And for these values, we're using x plus 2. This says including 0 and to the left. Including 0 and to the left, we use that. To the right of 0, we use that. And we'll stop there.